Hey guys, we're going to be talking about distance formula, which is in the section of your book called 16.1 and starting on page 779. You don't need to pull out your book unless you're dying to, which you're welcome to. But here's the deal. This question says, determine whether these segments have the same length. So we need to be able to figure out what the lengths of these things are and prove or justify if they're exactly the same or a little bit different. We're not going to do all four of these segments for this video. I'm just going to focus on two of them. And one is going to be segment AB. The other one that I'm going to focus on is going to be segment GH. Okay? So first let's deal with AB. So as we're dealing with AB, we need to figure out how far away those two are. Now if you turn this into a right triangle, you do something you probably remember to figure out the length of that hypotenuse. We'll call it little c. You know this formula. There's this handy dandy formula called Pythagorean theorem. And it talks about that if you take the hypotenuse and you square it, it's got to equal the length of the two legs squared and added together. A squared plus b squared equals c squared. Ka-chow! Well, I'm going to call this little side across from A little a, and I'm going to call this little side over here little b. All right, well, how long is little a? Let's just count. 1, 2, 3, 4, 5. Boom. 5. Square it. Add it to little b. 1, 2. 2. Square it. Add them together. Now remember, the whole point of a video is you can pause and rewind if you need to. 1 time, 10 times, a million times. If you're not sure where these numbers are coming up from, pause, rewind, go back again. All right, so 5 squared is 25. 2 squared, 4. 25 plus 4 is 29. So this tells me the hypotenuse squared is 29, but I don't want the hypotenuse. I just want, or I should say, I don't want the hypotenuse squared. I want the hypotenuse. So I got to take the square root. That is how you undo a squared. Take the square root. Well, technically, we should undo it with a positive and a negative square root, but we're talking about the length of something. We only need the positive version. Bada bing, bada boom. The length of segment AB, if I turn this little c, change it to, hey, AB, the distance between A and B is square root of 29. Sweet. So I can take this off, and I know that this is now the square root of 29. Now let's deal with segment GH. All right, so segment GH. Let's also use this new thing called the distance formula. But the best part about this is it's straight from Pythagorean theorem. And I'm going to show you that connection as we go. So distance formula says, okay, if you want to find the distance between 2 points, let's call them G and H. So GH equals, well, what was the last step we had to do down here? We had to take the square root of something, right? Well, let's just go ahead and write that in. We're going to have to take the square root of something. How did we figure out 5? Let's look. How did we figure out 5? Well, we just counted, technically. But what we did is we looked left and right, kind of like if we had subtracted the x values from A to B. Well, that's what we're going to do here. So let's say we know that the coordinates of G are -2, and I don't care about the y's yet. And the coordinates of H, it's the x value is at 2 something. I'm just going to deal with the x's for a second. To figure out how far apart these are, you could count or subtract the x's. 2 minus, whoops, that's not what I wanted. 2 minus -2. Okay? Well, what's 2 minus -2? Oh, be careful. Minus and negative means you add them. Now, what did we do with the length of this over here? We squared it, right? So we're going to square that right there. The distance between the x values, we square it. All right, now the other, which by the way is 16. Now the other thing we got to do is we got to deal with the y's. Okay, so the y value on G is -4. The y value on H is 0. So let's subtract them again. So 0 minus -4 that's just, be careful, 4. Formula says we're going to square it just like we did over here. We figured out how far up and down that side went. It went up 2. Well, this one goes up 4. Okay, it goes up 4, and you square it. Eventually, we're going to take the square root. Let's see. 4 squared is, it's 16 again. All right, well, what's 16 plus 16? It's 32. Well, hey, square root of 32. Now, here's the annoying thing. Those two segments originally looked like they were pretty darn close. This looked like it was about the same length as this guy. But it turns out they are not the same length. It turns out AB is the square root of 29. And GH is the square root of 32. Which is not the same. Okay? So if we were going to write all that stuff down to the final answer, we would say, all right, well, the length of AB, the distance between points A and B was the square root of 29. But the distance between G and H was the square root of 32. Those are not equal to each other. Okay? In words, you might say the length of segment AB. And if you say segment, you got to draw a little symbol above there that means segment. Does not equal the length of segment GH. So we put that little symbol above there. Okay? Now remember that formula we were talking about a second ago? Distance formula you guys already know. This new formula, Pythagorean theorem is a formula you already know. This new formula is straight from it. And it says take the square root of a bunch of stuff. The stuff you're going to take the square root of, subtract the x's, square it. Subtract the y's, square it, add them together. Now, I've had students before say, what does the 1 and the 2 underneath there mean? This little guy and this little guy. What do those things mean? That just means there's 2 of them. So if you're talking about the distance between 2 points, x1, y1, and the other point, x2, y2. It's just that you know there's a difference. There's 2 points going on. Bada bing, bada boom, it's a distance formula.